Hello students, and welcome to our lesson on slopes and slope-intercept form. What we're going to be doing today truly is just talking about slope and how we can use it to not only describe lines, but to help us graph lines and also to solve a few real-world applications. So let's go ahead and dive straight into it. With the slope of a line measures its steepness and direction and is often described as rise over run. The reason it's described as rise over run pretty often is because of how the formula actually works. So if we have 2 points, which we will call x1, y1 and x2, y2, okay, if these 2 points are on the line, then we can calculate the slope by doing y2 minus y1 over x2 minus x1, where all we do is take the x and y coordinates from those 2 points, subtract the y's on top, and subtract the x's on bottom. But when we do this, let's just think about what's happening. If I have two y coordinates and I subtract them from each other, I'm finding the change in y. Okay, the change in y is how much the graph goes up or how much the graph goes down. Okay, depending on whether it's positive or negative. So we call that the rise because it's either rising or falling, right? On the bottom, we have x2 minus x1, which is the change in x, and that's how much it moves left or right over that time. We call that the run. Okay, so the run is the horizontal change, and on top, the rise is the vertical change. Now we're going to end up in one of four different cases. Okay, a positive slope. So if we solve that formula and get a positive number, that means the line rises from left to right. Okay, that means it's an increasing line. And conversely, if it's a negative slope, that's going to mean that the line falls from left to right. So whenever we're talking about this, think back to arithmetic sequences. Remember that slope is the common difference. If the common difference is positive, that means our function is growing. Our sequence is getting bigger and bigger. But if the common difference is negative, that means our terms are getting smaller and smaller because we're subtracting each time. All right, but we have two that are a little bit weird. Okay, a slope of 0 is going to be a horizontal line. Okay, that means you don't go up or down at all. You just go left and right. And a slope that is undefined is going to be a vertical line. So now let's real quick just understand why those two are true. So a slope of 0 is horizontal. What the slope might look like if we get 0 is 0 on top and let's just say 7 on bottom. So how do we get to a slope of 0 like that? Well, on top, we would have that the y coordinates, y2 minus y1, gives us 0. That means that the line doesn't go up or down at all, right? This y2 minus y1 measures how much it goes up and down. So if that's 0 on top, that means it did not go up or down. Okay, so this just results in a horizontal line, a line that doesn't go up or down. But an undefined slope would be the upside down version of that. So an undefined slope would mean we might have something like 7 over 0. So now how do you get a 0 on bottom of your slope formula? Well, the bottom is x2 minus x1. It's how much we move left and right. So if our denominator is 0, that means that we didn't move left or right at all. All we did was go up and down. So that's going to result in a vertical line, a line that only goes up and down but doesn't go left or right. So now we can draw a couple pictures of these. Let me just label 7 over 0 as being undefined real quick. So a positive slope is going to go up and to the right, something like that. A negative slope will go down and to the right. A 0 slope will just be a horizontal line. And an undefined slope will be a vertical line. So now what we're going to see later in the lesson is examples of what these lines might look like, but I want to give you an example here real quick. For the positive slope, we might have y equals 3x, where the slope is 3. It's positive, okay? For a negative slope, just imagine y equals negative 3x, where all we do is take that slope and make it negative. That's going to cause it to go down. A slope of 0 might look something like y equals 4. Okay, now why is it just a number? Why is there no x? Well, remember that the thing attached to the x is the slope. So if our slope is 0, The reason we get something like y equals 4 is because we would really have y equals 0x plus 4 potentially as our equation, but that 0x is just going to disappear. So all that's going to be left is y equals a constant, and that constant is where our horizontal line will be. Now, I want to be clear real quick. These examples I'm giving here do not match the lines that I drew up here. Okay. In the future, later in this lesson, we're going to actually graph lines and see them. These are just example equations that do not match the lines. All right, that last one, that undefined slope, this is the one that gives students a little trouble. This is going to be x equals a number. Okay, so that one's a little bit harder to understand, but what's happening here is no matter which point on this line you choose, the x value equals 1. And so what happens is that the y value can be anything as long as x equals 1. So this equation x equals 1 just tells us that the x value is not changing. Our line is always on this line right here where x is 1. But the y value can be anything. So if y is 3, the point's up here. If y is 0, the point's down low. Okay, so x equals 1 or x equals any number is what's going to give you that vertical type line. All right, let's do some examples of finding slope now. So number 1, we want to find the slope that goes through the 2 points given, 1 comma 2 and 4 comma 5. So the first thing we're going to do is label our points as x1 y1 and x2 y2. That way we can use the formula where m equals y2 minus y1 over x2 minus x1. Now, it does not matter which point is which. Okay, it does, however, matter that x1 and y1 are together. So this first point could be x2, y2, or x1, y1, but the subscripts, these ones here, have to be on the same point because they refer to this as point 1. So x subscript 1 means the x value of point 1, and then y sub 1 is the y value of point 1. So x1, y1 just have to be together, but it doesn't actually matter which point is which. All right, so now let's actually plug these in. We are going to have 5 minus 2 on top. And then on bottom, x2 minus x1 is going to be 4 minus 1. And then all we have to do is simplify this fraction. We end up with 3 on top and 1 on bottom. Sorry, 3 on top and 3 on bottom. So 3 over 3 is just going to simplify to be 1. So the slope of our first line is just 1. Through those 2 points, we have a rise over run of 3 over 3, which is just 1. For number 2, we're going to think of the first point as x1, y1, and the second point as x2, y2. So m is going to be equal to y2 minus y1 over x2 minus x1. But notice when I plugged that in just now, I have minus a negative on bottom because my first x here, x1, was negative 3. So I need to do minus a negative 3 on bottom. When I simplify this, I get 0 on top, and 2 minus negative 3 gives me 5 on bottom, because it's really 2 plus 3. 0 over 5, though, is just 0. So for line number 2 here, I have a slope of 0 through these 2 points. For the third one, we have 0, negative 1, and 0, 4. So if I calculate my slope, y2 is 4, minus y1 is negative 1. Notice I'm subtracting a negative, so I put it in parentheses. And on the bottom, we have 0 minus 0. So this comes out to 5 over 0. That is undefined. Okay, so for this third example, our slope is undefined. Now, number 4, we want to find the slope of the line, and we are given a graph this time instead of 2 points. That's only technically true, though. Okay, we really are given plenty of points. They just aren't labeled yet. Okay, we can see them on the line, but we have to go find them. So I can choose any 2 points that are nice, clear, and obvious. So I'm going to choose the point 0, 1, which is the y-intercept, and I'm going to also choose the point 4, comma 3. Now, I could have chosen any nice points, and by nice, I just mean they fall on a nice corner point, so you can cleanly read them. But I chose those 2 because they're kind of nice and spread out, easy for me to see. So when I calculate the slope now, I'm going to use 0, 1 as my x1, y1, and 4, 3 as my x2, y2. So my slope formula is going to do 3 minus 1 over 4 minus 0. This comes out to 2 over 4, which is 1/2. And so the slope of my line here is just 1 over 2, 1/2. So now I want to point out something real quick, that I got 2 over 4 and then I called it 1 over 2. Those are equivalent fractions. All right, we've learned all about fractions in this class. Equivalent fractions give you equivalent slopes. So in problem 1, we had 3 over 3 was equal to 1. Really what I mean is that a rise of 3 and a run of 3 is equivalent to a rise of 1 and a run of 1, because 1 is really 1 over 1. So these are equivalent fractions, which means 3 over 3 is equivalent to 1. Just like here, 2 over 4 up 2 right 4 is the same as up 1 right 2. You just have to do it twice in order to get to the unsimplified version. So 2 over 4 and 1 over 2 are the same slope. They're just equivalent fractions, so different ways to represent that same slope. All right, so now we're going to actually practice graphing. So we found slopes a second ago. Now we got to put some graphs on the paper. What we're going to be working with here is slope-intercept form, which we've seen in the previous lesson is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, and in order to graph this, what we're going to do is we're going to first graph the y-intercept, which is 0 comma b. Okay, that's the definition of a y-intercept, is it's 0 comma that y-intercept value. So in this case, that's our b value. And then we're going to use the slope to find the next point on the graph by using the rise over run to go from one point to the next. And then we'll connect those points with a line. So for number 5, it says to graph each line using slope-intercept form, we're given y equals 1/2 x plus 3. My y-intercept right here is 3. So the point 0 comma 3 is automatically on my graph. So I'm going to go right ahead and graph 0 comma 3. And now that I have my y-intercept, all I have to do is find one other point, and then I can go ahead and draw a line through them. So the way we use our slope, which is this 1/2 here, this means up 1, right 2. Okay, rise over run there, up 1, right 2. So from my blue dot, I'm going to go up 1 box and right 2 boxes. So up 1, right 2 takes me to this red dot here, which is going to be, because we went up 1, right 2, this is now 2 comma 4 is that new point. And then all I have to do is draw a line through them to connect. But do you see how my dots are really close together? It's a little inconvenient to draw an accurate line when your dots are that close. So what we can do to make our line a little bit easier to draw is just add a couple more points. So if I keep using that same slope, up 1, right 2, I can, from my red dot, go up 1, right 2 again, up 1, right 2 again, up 1, right 2 again, up 1, right 2 again. And see how now it's a little bit easier to see the line forming? Okay, so that's to the right, but what if I want to go to the left, right? How do I go to the left? Well, let's look at the rightmost dot I just drew. How do I go from that rightmost dot to the left of it? Well, when I went the other direction, I went up 1, right 2. So the opposite of up 1, right 2 is left 2, down 1. Left 2, down 1. So if you want to go the other direction, you just reversed what you were doing. So from my blue dot, I can go left 2, down 1, left 2, down 1, left 2, down 1, and now I have more than enough dots to be able to draw a nice line through them and put an arrow on each side. All right, number 6. We want to graph y equals negative 2x minus 1. Negative 1 is our y-intercept here. That's our b value. So that means 0 comma negative 1 is on our graph. So I'm going to graph the point 0, negative 1. And now we want to use our slope to find more points so we can draw a line. My slope is negative 2. Negative 2 is really negative 2 over 1. So that means down 2, right 1. Okay, down 2, right 1. So from my blue dot, I'm just going to go down 2, right 1. Down 2, right 1. Down 2, right 1. And I do this until I have enough dots that I feel comfortable drawing my line, which I already do. But now let's think about, how do I go the other way? Okay, why does it work to go both directions? Well, real quick, I'm going to do a little aside here. Negative 2 over 1 is our slope. Okay, we know that this equals -2. Okay, it's really just -2 over 1. That is mathematically the same as saying 2 over -1. So now why do I care? Well, -2 over 1, we already said, meant down 2, right 1. So the opposite of that would be going the other direction. Okay, but notice that 2 over -1 still equals -2. But now the 2 on top means to go up 2, and the -1 on bottom means to go left by 1. So by just moving the negative sign from the top number to the bottom number, it reverses my slope. So instead of doing down 2, right 1, I can equivalently, let me just move this over here real quick. Oh, that was a bad method for moving it. Let me try that again. Sorry for the delay, team. All right, so instead of going down 2, right 1, I can go up 2, left 1. And this is going to take me the other direction on my line. So from my blue dot on the graph, all I'm going to do is go up 2, left 1, up 2, left 1, up 2, left 1. And I feel like I have plenty of dots now, so I'm going to go ahead, draw a straight line through them, put an arrow on each side, and my line is graphed. All right, now let's do the special cases. Number 7 says y equals 4. Y equals 4 is the same thing as saying y equals 0x plus 4. We just don't write the 0x because it doesn't give us anything here. But in terms of slope, it's nice to know that here the slope is 0. And the 4 is our y-intercept, so 0, 4 is on my graph. So I'm going to plot the point 0, 4. And then now I'm going to use my slope. A slope of 0 means to draw a horizontal line. So I'm not going to add any points here. I'm just going to draw a line horizontally through my y-intercept. And boom, we are done. That is the line y equals 4. Notice that the y value is 4 for that whole time, but we go infinitely far to the left and to the right. Number 8 is very similar, just the other direction. We have x equals -3. I don't have a great way of explaining, quite honestly, how to look at x equals -3 because it's really not in slope-intercept form. Okay, we can turn y equals 4 easily into 0x plus 4. But for x equals -3, we really just need to think of it automatically as being a vertical line, where the x value of our vertical line is this 3. Same thing for number 7. Although you can do what I showed you here by writing 0x plus 4, I don't recommend it. I recommend you just know that y equals 4 is a horizontal line, where the y value is 4. So x equals 3, I want you to just think of it immediately as it's a vertical line with an x value of 3. So all we're going to do is go to our graph where x is 3, and we're just going to draw a vertical line through x equals 3 here. So now let me real quick work backwards and show you why this results in an undefined slope. If I pick any 2 points on this graph, like 3, 4 and 3, 2, and I try to find the slope between these 2 points, I would do 4 minus 2 on top and 3 minus 3 on bottom, but notice that gives me 2 over 0. Okay, so whenever we have a vertical line like this and we try to find the slope, we're always going to get a 0 in the denominator. And so that makes it so we can't actually write down the slope in slope-intercept form because we're not allowed to write an undefined value in our equation. We can write a 0 in our equation like we did in number 7, but we can't write this undefined value here. So that's why number 8's a little weird. We just need to know that x equals 3 there is going to be a vertical line at 3 because the x value is always 3, but the y value can be whatever it wants. All right, now we're going to extrapolate this to a couple applications here. And this is really why this is valuable, is because we can use it in real life to make some informed decisions, or at least to better understand situations that we're in. So we're going to be interpreting slopes now and using them to make some decisions. So slopes in general are constant numbers, meaning they do not change. They're not variables. The slope is always the slope for a linear equation. And they represent the ratio in change in y to change in x. So now right now, x and y don't have any meaning, but in the problems below, they're going to have meaning. We're either going to be talking about miles or volumes of fluids or dollars, okay? But we're going to have some sort of units that go with X and Y. And our slope is going to represent how one of those variables changes with respect to the other. To find the slope in context, all we have to do is identify 2 points, x1, y1, and x2, y2. And then just like before, we're going to calculate the slope between those 2 points. So the only new challenge there is we have to identify what these points are. But once we've identified them, we find the slope in the exact same way. And then we use the problem to interpret the slope using the appropriate units. So that might be dollars, it might be miles, whatever it may be, but we need to put some sort of interpretation on it. And then once we have this information, then we can use that interpreted slope to find other points of interest in the problem, which we'll have to do for each of these. So first one, number 9. A family is driving to visit relatives. At the start of the trip, they are 500 miles from the destination. 3 hours later, they are 320 miles away from that same destination. We want to interpret the slope in words and predict how far they will be from the destination after 6 hours. All right, so we need to uncover 2 points here. We have that at the start of the trip, they are 500 miles away. Okay, whenever it says you're at the start of something, we're going to use that as our x value. Okay, so since later on it says hours, we're going to use x hours as our x value. So at the start, it's been 0 hours. And then we're going to use the miles as our y value. It's going to be our distance from where we're going. So I'm going to set 500 as my y value that corresponds with 0 hours. So that point right there, 0, 500, means after 0 hours, they are 500 miles from the destination. Similarly, we have this line down here that says 3 hours later, they are 320 miles away. So my x value, the number of hours it's been, is going to be 3, and my y value, their distance from the destination, is going to be 320. All right, so now I can go ahead and find the slope between these. I have 0, 500 is my x1, y1, and 3, 320 is my x2, y2. So when I find slope here, I do 320 minus 500 divided by 3 minus 0. This is negative 180 over 3, which is negative 60. So now we have to think about what this means. Okay, so we need to bring units into this. When I set up what my x values and y values are, I said that my x values, which are 0 and 3, represent hours. So that means the denominator of my slope there, 3 minus 0, these are hours as our units. On the top of my fraction, though, I have the y values, which we said represent miles away. So I have miles on top and hours on bottom. When you have miles divided by hours, that gives you the unit miles per hour. So this negative 60 here, so m equaling negative 60, is that they are driving, let me spell driving correctly. They are driving 60 miles per hour towards the destination. So now, why do I know it's towards the destination? Well, we got a negative 60 as our slope, and the y value represents how far they are away. So they're getting closer and closer, right? We went from 500 miles away to 320 miles away. So we're getting closer to the destination. So although the slope is negative, when we interpret it, we use the absolute value and we say which direction they're going. So a slope of negative 60 here means they are driving 60 miles per hour towards the destination. Okay, so now that being said, we're going to do part 2 of the question, which says predict how far they will be from the destination after 6 hours. Okay, if we write an equation based off what we've done so far, we're going to have that y equals, our slope is negative 60, that's what we just found. And for slope-intercept form, it's the slope times x plus the y-intercept. Our y-intercept from the beginning was the 500 number, okay? Because we have 0, 500 as a point on our graph. That's how far away they start. So we have an equation of our line, we want to use this to predict how far they will be in 6 hours. So we're going to take this number 6 here and we're going to plug it in for x. Because remember, x represents how many hours it's been. So we are going to have y equals negative 60 times 6 plus 500. This is negative 360 plus 500. And so y is equal to 140. Now we just have to put some units to this. We got y equals 140. Remember that our y values here, the 320 and the 500, represent the miles from the destination that they are. So if we get y equals 140, that means that after 6 hours, they will be 140 miles away. So it says predict how far they will be from the destination after 6 hours. Our prediction is 140 miles. Okay, not so bad, right? We had to find a slope and then use that slope to write an equation of a line and then plug in a new x value, a new number of hours. So we did 3 different things there, or 4 different things if you count having to find the points. So we found points, we found slope between those points, we found out what that slope means so we could write an equation, and then we calculated a new prediction by plugging in 6 hours. All right, let's try number 10. A nurse begins an IV drip with 800 milliliters of fluid. After 2 hours, 650 milliliters remain. Interpret the slope in words and predict when the bag will be empty. So we need to uncover 2 points from this. We have that a nurse begins with 800 milliliters. And then later on, after 2 hours, there's 650 milliliters left. So just like the previous problem, we're going to let our x value be the number of hours, and our y value in this case is going to be the number of milliliters remaining. So our first point will be after 0 hours, there's 800 milliliters. And our second point is that after 2 hours, there's 650 milliliters. Okay, we can use that to find slope real quick, where m is going to be equal to 650 minus 800 over 2 minus 0. This comes out to negative 150 over 2, which is negative 75. So now in the context of the problem, it says we began an IV drip, and after 2 hours, we have less milliliters in there. So negative 75, it's negative because we're losing or using this IV fluid. Okay, so what we can say, this negative 75 as our slope means the IV is dripping at 75 milliliters per hour. Okay, and the reason we call it per hour is because our numerator represented the milliliters of IV and our denominator represented the number of hours. So we're doing milliliters divided by hours, which means milliliters per hour as our units here. So that IV is dripping into the patient at 75 milliliters per hour. So we've interpreted the slope. Now we need to predict when the bag will be empty. Oh, what does empty mean? Well, empty should mean that there's 0 milliliters left. Okay, so the first thing we're going to do is write an equation that models this like before. So in slope-intercept form, we have y equals our negative 75 was our slope, plus the 800 milliliters we started with. So very similar to the previous problem's equation. But now it's different. We're not told how many hours it's been and we want to make a prediction. We're told how much fluid is left. And the amount of fluid left is nothing. So when it says how predict when the bag will be empty, when means after how many hours, and empty means y equals 0. So I'm going to put a 0 in here for y, write the rest of my equation as is, and because we're solving for when, that means we're solving for that x value. So this is now just a normal 2-step equation. I'm going to add 75x to both sides. So you get 75x equals 800. And then I'll divide both sides by 75, which is going to reduce to be 32 over 3. And real quick, let's just double check what 32 over 3 is. So right here, we can do 32 divided by 3 gives me 10.666, and the 6's keep repeating. So in this case, because we're talking about a number of hours, if someone asks you how many hours it'll take to empty and you say 32 over 3, they're going to look at you like you're crazy, right? They're going to say, hey, give me an actual number, please. And so, although 32 over 3 is the most accurate answer, for real life purposes, for communicating with people, we're going to give them a rounded decimal. So, we're going to say 10.7 hours. Okay, so we're going to say this is approximately 10.7. And because we're predicting when the bag will be empty, we got to throw that as units on there. This is 10.7 hours is going to be our final answer here for our prediction. So again, 32 over 3 is the most accurate number of hours, but in real life, nobody wants you to tell them 32 over 3 hours. Okay? We would much rather communicate in a rounded decimal in this case. All right, number 11. 2 hours into a job, a contractor has already earned $380. After 5 hours of work, the total earned is $650. Interpret the slope in words. How much will the carpenter make if it takes 8 hours total? Okay, so we have something a little bit different here. We have 2 hours into the job, $380. So it's not at the start of the job. Now it's 2 hours in. So this is going to be the point 2 comma 380, where the X represents hours and the Y represents money earned. Then it says after 5 hours, the amount earned is $650. So similarly, we're going to have the point 5 hours, comma, $650. So hours and dollars, hours and dollars. If we find the slope between these, we're going to do 650 minus 380 over 5 minus 2. This comes out to 270 divided by 3, which equals 90. So now let's think about in words what is actually happening here. After 2 hours, $380. After 5 hours, $650. So in between those two amounts, the carpenter is earning an additional $90 per hour. Okay, so the carpenter is earning $90 per hour from hour 2 to hour 5. So between hour 2 and hour 5, $90 per hour. At the end here, it says, how much will the carpenter make if it takes 8 hours total? So now this part's a little bit not so obvious. Okay. Notice that the original amount the carpenter had here was after 2 hours, $380. 2 times $90 is not $380. Okay. So that means that this carpenter earned $200 before doing any work, because 2 times 90 is 180 and 380 is $200 more than that. Okay, so per hour, the carpenter is earning $90, but the carpenter earned $200 before they even started working, because that's how they had to get to this 380 number. So maybe that $200 covers the expenses of the materials. So now when it says how much will a carpenter make if it takes 8 hours total, we can't just multiply 90 times 8, because that's not going to account for the extra $200 at the beginning. So instead, we need to use the fact that it's going up by $90 per hour. So we're going to think of this as a sequence instead of as an equation. So we went from 380 in hour 2, so I'm going to label that with a 2, to something in hour 3, something in hour 4, and then in hour 5, 650. So because we already know the slope, we know that we're going up by $90 per hour. So 380 plus 90 would have been 470 in hour 3, and then 560 in hour 4, and then we get to that 650 in after 5 hours. So if we want to know how much the carpenter is going to make after 8 hours, we can just keep going all the way to 8. So if I add 90 again, I'll get to 740 after 6 hours, 830 after 7 hours, and finally 920 after 8 hours. So we can go ahead and conclude that after 8 hours, the carpenter is going to make $920 total. Okay, not so bad, but we didn't do it using equations. So what if instead of 8 hours total, it was like 100 hours total? How would you have calculated this instead? Well, we just have to think back to sequences and think how many times did we have to add $90? So to go from hour 5 here to hour 8, we had to add 90 1, 2, 3 times. Notice that 8 minus 5 is 3. So what we could have done instead of what we did do is we could have taken 650, which was the amount in after 5 hours, and added 3 times 90. So notice 650 plus 3 times 90 is 650 plus 270. That is also going to equal 920. So in this case, we could have done it a much quicker way, which is to just add 93 times to get over to the after 8-hour number. But either way you do it here, we're going to get to 920. The only thing that students would likely do, which is wrong, is to take the 8 hours and multiply by the 90 right away to get $720. But notice that that would be $200 short of what the carpenter is actually expected to make. All right, number 12. This one's going to break our brains just a little bit. Just a little bit. Okay. It says a cell phone battery has 100% charge at 8 a.m. At 2 p.m., it is down to 28%. Interpret the slope in words. At what time will the battery hit 0% if the rate continues? So now, the obvious thing to try to do, based on what we've done in the past couple problems, is to say that 8 a.m., so 8 is the x value, and 100%, which is the charge, is the y value. So a lot of you guys would go straight to 8 comma 100, and you'd probably feel pretty good about it based on what we've done so far. It's not quite what we need though, okay? Because the 8 is not really an 8. So think about earlier in number 9 and number 9 and number 10 really, where in number 10 we said the nurse begins an IV drip with 800, and at number 9 it says at the start of the trip it was 500 miles away. Notice they didn't give us a time, and we didn't need a time. So here we're given 8 a.m. We don't really care what time it is though. We just care that this is when the phone is at 100%. So we're going to call that the start time. Okay, we're going to refer to 8 a.m. right here. Okay, 8 a.m. is the start time. So start time of 8 a.m. So I'm going to consider that to be after 0 hours. So notice now I have 0 100 as my first data point instead of 8 100, because that is the start of our timer. Then it goes on to say that at 2 p.m. it's down to 28%. So again, you might be tempted to say 2 comma 28, which is close, but not quite. Okay, because we need to think, if 8 a.m. is the start time, okay, 8 a.m. is the start time, that means 2 p.m. is after 6 hours. Okay, it takes 6 hours to get to 2 p.m. from 8 a.m. So this is going to be 6 comma 28 instead of 2 comma 28. Okay, we need to account for how much time has passed. We don't really care what time it is in this case. We need to know how much time has passed. So now we can calculate the slope. We have 28 minus 100 divided by 6 minus 0 is going to give us negative 72 over 6, which is negative 12. So we can interpret this by m equaling negative 12 is the battery uses 12% per hour. So every hour we're losing 12% of our battery. And now what it wants us to calculate is when will the battery hit 0%? So now we're going to do something similar to what we did in 9 and 10, where we're going to set up an equation. That way we can then solve for when it will hit 0. So our equation, we know that it starts at 100%, and we know that the start time is 8 a.m. and that the slope is negative 12. So we're going to go with y equals negative 12x. That's our slope times x. And we don't care about 8 a.m. yet. We just care that it starts off at 100%. So my y-intercept is 0, comma 100. Notice again, 0, 100 right here. And so 100 is my y-intercept. Now it says when will it hit 0? So 0% is the y value we're trying to solve for. Because notice my 100 and my 28 were percentages, and those were the y values. So we're going to set 0 equal to negative 12x plus 100. And then just normal solving steps. I add 12x to both sides to get 12x equals 100. And then we're going to divide by 12. So x is going to equal 100 over 12, which 100 over 12 is approximately 8.3. Okay, we could say 25 over 3, but we're going to use a rounded decimal here and say 8.3 is approximately what we have. So now we finally have to use the 8 a.m. thing. Because it says at what time, okay, not how many hours later, but at what time will the battery hit 0%? So we just found out that it'll take 8.3 hours to hit 0%, but now we need to actually say what time is that? So 8 a.m. plus 8.3 hours is an actual time. So let's go ahead and figure that out. 8 a.m. plus 8 hours takes us to 4 p.m. And so we're going to say it's 4.3 p.m. Now, does that feel wrong? Okay, do you feel satisfied with that answer? Probably not. What is 4.3 p.m.? We don't know. And so we need to give a better answer than this, right? 4.3 p.m. If you say that to someone, they're going to look at you like you are absolutely crazy. So what we need to do is find a conversion between that 0.3 and the number of minutes in the time, because we don't want to say 4.3. We want to know 0.3, what is that in minutes? Okay, so real quick, let's do a little calculation. There are 60 minutes in an hour. So 60 minutes multiplied by 0.3 is the number of minutes that a 0.3 hours represents. So 60 times 0.3, we can calculate real quick. Okay, that gives me 18. So I know that 18 minutes is how far past 4 p.m. it is. So if 8.3 hours is 8 hours and 18 minutes, then this is going to take us to 4:18 p.m. Do not you dare say 4.3 p.m. to anyone, because they're going to look at you like you're a madman. Okay, so we need to be able to convert there to get to minutes. Now, in this class, we do not have a dimensional analysis unit, but I do want to point out that on the cover of your booklet, there is actually a mention of dimensional analysis when we talk about screen time and how much time per day or time per year or time until retirement you spend on your phones. So although we don't explicitly have a dimensional analysis unit, meaning a unit conversion unit, we do have that initial problem. And so hopefully this is not too bad for you, but officially not a part of the class, not a competency. However, in the next course, you'll go through a lot of detail about how to do this conversion here from minutes and hours into, well, just minutes in this case. So more about that in the future of mathematics for you. But for right now, we're going to call it quits at 4:18 p.m. is when your phone died. And hopefully you do not have your phone dying at 4 p.m. every day. Okay, stay off your phones, stay in school, go learn things, go touch some grass, and I will see you in the next one.